Hi everyone, my name is Lydia and this is what I wish they taught me about econometrics and introduction. In the previous videos, we've seen the level model, the intuition, the mathematical derivation. So in this video, we're going to work through a concrete example and interpret the coefficient properly. So suppose that the estimated model that we have is wages hat equal to 20,000 plus 2,500 education. If you remember from my previous videos, I have emphasized quite heavily on the fact that you need to familiarize yourself with the measurement units of the variables in your dataset. So the next step that I should be doing for us to be able to do the interpretations correctly is give you the measurement units for both wages and education. And in here, we'll say wages is measured in, let's say, pounds per year. And education is years of schooling. From the information that we get here, we can see that beta null hat is the 20,000 and beta 1 hat is 2,500. Okay, so very quickly for the beta null hat in here, keep in mind that we said that this is what we would get when our x is equal to 0, meaning years of education is equal to 0. It means that if you have no education, you'll find a job that on average will give you 20,000 pounds per year. Now, whether that is economically significant or statistically significant, that really depends on the kind of data. Most of the times, these numbers are not really economically significant, and you will have to check a little bit more closely wages by itself in the actual data set that you have to see whether these 20,000 makes economical sense for that sample that you have calculated or covered in your study. Okay. Sometimes it can be statistically significant, but that does not mean that economically it also is significant. So always be very aware when you are interpreting beta null when you have actual data. If you have a simple given regression like this and you're just simply asked to do the interpretations just so that they can check your understanding of the interpretations, then you can say it is on average 20,000 when education is 0. Now, moving to beta 1 hat being equal to 2,500. The interpretation that we're going to make in here is that a 1 year increase in education is associated, and I'm going to underline associated here, with an increase in annual wage by 2,500 pounds. Okay, or off, like whatever is easier. Okay, now the reason why I underlined associated in here is because keep in mind, we haven't really established causality in here. So things are like estimations are always on average, and that's why we always use words like associated with, not causes a. Okay, so a 1 year increase in education is associated with an increase in annual wage by 2,500 pounds, which means, again, unit of education is years and unit of wage is pounds. So the unit, all right, unit of the slope is pounds per year of education. Remember when we said the measurement units, they travel with the slope. Okay, and this is a key habit that you have to start building. So familiarize yourself with the measurement units and make sure you always use them when you're doing and giving context to the actual interpretation. Okay. Now, how can we give an insight to that constant effect through the model that we have in here? that is quite simple actually, because based on this model, and I'm just going to take this model with us below here, we can make actual predictions for certain levels of education. And you can compute what your wages is for education going from 10, and then the same for wages when education is 11. The way that you can do that is simply by substituting education 10 into the actual regression. So here you'll have 20,000 plus 2,500 times 10. And here you have again another 20,000 plus 2,500 times 11. Okay, so you see the delta x in here is 1 because we're going years of education 10 to 11. If we look at like, well, what about the changes in my y of wage? Well, we can just simply do a subtraction of these two values in here, and very clearly the 20,000 cancels out with each other. So you're actually left with 2,500 times 11 minus 2,500 times 10, which is very clearly just 2,500, and it's just our beta 1 hat. Okay? And the thing is, it won't matter if you do this computation for 10 or 11 or for 15 to 16. Keep in mind, what's going to change is that this 10 now is going to be 15 and the 11 is going to be 16. And you're going to have here 16, 15. The difference is going to be all over again 2,500. And that was that defining property of the level moment. So it does not depend on the starting level of education. Is just that beta 1 hat in here. Okay. Also, by doing these kind of substitutions in here, what you should get is like another key takeaway from this video is whenever you want to compute predictions, all you have to do is plug in the levels that you want for your x variables so that you can find what that prediction is. Okay? Now, what would be common exam mistakes that you could be making? Be aware that some students in the nervousness of being in an exam or in the rush of trying to get one more question done during an exam, they might say that, well, wage increased by 2,500%. That is wrong. Okay, so we know very clearly these are here the units. The other most common mistake that I see is that actually students mix up the interpretation and they say that 1 year increase, that let's say 1 pound increase in wages is associated with 2,000 pound, like 2005 years. Okay, so in this case, it's very clear that that interpretation will not happen because you can't think of 2,500 years, but if it was another unit, that it wouldn't be so bad to say 2,500, I don't know, centimeters or liters. In that case, students might not think much about it and they swap the two units and they swap which is the one that increases by 1 unit and the one that increases by the beta 1 unit. So always be very careful. Write down what those measurement units are and make sure that you are using them at the correct place when you're doing your interpretation. I hope this was helpful, and I'll see you in the next video.